Hello everyone, welcome to the channel Exam Ignite. Continuing the module 4, this is a part 2. In the part 1 it is already explained, and in the part 2 we are starting with the magnetic field concept, where firstly magnetic pole strength, that is that we have to know the definitions for the exam point of view. That is why I have made a easy, possible, understandable definitions and the derivation. We'll go with that. Magnetic pole strength, it is said to be the unity. It is said to be unity if it experiences a force of 1 Newton when placed at a distance of 1 meter from the similar one in the air or vacuum. Magnetic field, it is a region where a magnetic pole experiences a force. It's called magnetic field. Magnetic moment, it is a product of magnetic pole strength and the distance between the poles. Magnetization, it is a magnetic moment by unit volume of the magnet, that is capital M is equal to small m divided by V. Magnetic susceptibility, it is the ratio of M to strength of the field, that is X is equal to M by H. Then magnetic field intensity is H, where H at any point in the magnetic field is equal to and directed along the force experienced by the unit north pole of the point. Magnetic flux density is B, which is flux by area of the plane surface. Permeability, it is the standard reference with respect to which the permeabilities of the other materials are actually expressed. So mu naught is value is 4 pi into 10 power minus 7 Henry per meter, and for the absolute permeability you have to multiply mu naught into that mu r. Nextly, the most important and the most expected, and it is a two short question, which is a magnetic boundary condition. Firstly, it is explained very easily. You have to write the considerations. That's it. Like consider a medium 1 and medium 2 and a rectangular block which has an H1 and HL1 and HL2 with a consisting of a length L1 and a height H1. Like that, you have to write some of the condition with the magnetic field of H1 and H2. So Maxwell's equation, we know by the Maxwell's equation, that is integration of H vector dot dl vector is equal to surface integral of j vector plus dou d vector divided by dt into ds. So integral of surface vector j vector dot ds, split it out in plus integral of dou d vector divided by dou t into ds. This will be considered as equation 1. Now, when h tends to 0 and delta s tends to 0, what happens is this terms becomes completely 0. So we get dou d vector divided by dou t into ds vector will be 0. But what happens is this remains the same. But this is actually the current density normal to the loop. Current density is normal to the loop, hence this does not become 0. Now you have to put this equation 2 and you obtained equation 3 in our main equation 1. You will get it as integral of h vector dot dl vector is equal to js dl, which is the equation 4. h1 and h2 are what? Which are the tangential components of the magnetic field. So integration from A to B, that is from one point to another, A to B, ht1 into dl vector minus integration of C to D, ht2 into dl vector. We are splitting, which is equal to js into dl. That is, this integration is getting splitted. Or you can also write it as ht1 into this becomes delta dl minus ht2 into delta dl, which is equal to js into delta dl. Now on removing all the delta dl and it gets cancelled out, ht1 minus ht2 is equal to js. So in case js is 0, then we can say that ht1 is equal to ht2. This is the tangential. And you have to write the normal. Normal, you have to consider a magnetic field M1 and M2, and which is having, consider a cylindrical type surface, which is having a height of delta H and a surface of delta S. Magnetic flux on the top will be what? It is integration of B1 vector into ds vector. And for the bottom, it is minus integration of B2 vector into ds vector. Now, what's the integration of this B vector into ds vector is the difference of these two. You have to basically add that, but here minus is there, or it gets minus. So integration of B1 vector into ds minus integration of B2 vector into ds. So it is equal to B1 vector dot delta s vector minus B2 vector dot delta s vector. Maxwell's equation, we know that integration of B vector dot ds vector is 0. So put the 0 here. what happens here is an vector and an2 vector are what the unit vectors here we have observed. So we can change that as b1 vector into a1 cap minus b2 vector into a2 cap into delta s. So finally, this becomes bn1 delta s minus bn2 delta s. So on taking it to the left hand side, we get bn1 is equal to bn2, where delta s is 0. Therefore, the normal component of the magnetic field continues from the one medium to another medium. Mu1 hn1 is equal to mu2 hn2. So hn1 is equal to what? Mu2 hn2 divided by mu1 goes down. So hence we can say that here hn1 is not equal to hn2, but here ht1 was equal to ht2. So because it is not equal, because it is discontinued, that is because of the eddy current. Next concept is magnetic circuit, which is a closed path of magnetic field lines of force through one or more materials. So electric and magnetic analogies we have to know. That is, field equation for the electric is E is equal to minus dou nebula V. For the magnetic, H is equal to minus nebula Vm. Potential difference between the A and B is VAB is equal to integral of A to B, E vector or dl vector. Now here it is H vector dot dl vector. Ohm's law, we write it as J, it is the current density, is equal to sigma E vector, density E vector, V is equal to IR. B vector is equal to mu H vector, Vm is equal to mu psi s. I by I or J, you can write it as I is equal to integration of S J vector or ds vector. Psi is equal to psi is equal to integration of S P vector dot ds vector. EMF or MMF, V is equal to integration of E vector dot dl vector. Here Vm is equal to integration of H vector dot dl vector. For the resistance, you can R is equal to D by sigma A. Here S is equal to D by mu A. Closed path in the integral in field is integration of E vector dot dl vector is equal to D0, integration of H vector dot dl vector is equal to Ni. Reluctance of magnetic circuit. Consider a magnetic circuit with a loop of magnetic materials in which flux is set by using a coil of N turns in the I flowing. A is the cross section and L is the length of this. Then we know that B is equal to psi divided by A, that is, or phi divided by is equal to PA, but we know B is equal to mu H and H is equal to what? Vm by L. So substitute this H here, that is B is equal to mu Vm by L. Now put this B in this first equation. So phi is equal to mu of Vm divided by L, but we know phi is what? Vm by S. So we can directly write as S is equal to 1 by mu A. So this completes the module 4. Please do refer all the videos and go through them and prepare for your exams, or best of luck for your exams, and please do subscribe and share with your friends. Thank you.